Hello Glenala students, welcome to another lockdown lab. We're back again. Today we're doing a little bit of physics though. We're going to look at Newton's second law of motion. While you'll be doing that in next week's theory stuff, I did want to do the lab with you this week. I'm going to try to do it online as well. However, I want you to be able to see it running properly, just so that you can visualize a bit better. So, we have our familiar cart system. We've got a cart over here. Today we're going to be using the screw that's going to be attached to it. You might be able to just very faintly see that down there. We're running up to our end stopper, and then right at the end here you can see just off the edge is a pulley. You can see it spinning there as the cart moves along. And what pulleys do is they redirect force. They don't add any force, they don't subtract any force. All the pulley does is it redirects. Now, we don't need to do much with pulleys, I'm just showing you what the equipment is. And off the end of the pulley is a little mass hanger where we're going to slot some 50-gram masses. Now, if I pull this back to here, make sure the string stays on the pulley. I've pulled this back, there's a string attached to the front of the cart, there's a mass hanging off the end of it. What do you think is going to happen? Yeah, it's going to get pulled. Gravity's going to pull down on that, and that pulley here will transmit the force of tension over to my hook here, and that's going to go. Right. And you can see a little bit, this shifts a touch as it collides at the end. Lovely bit of conservation of momentum and energy. So what we're going to do today is we're going to change the mass of our system, and we're going to measure the acceleration. And because I'm going to add some masses to the end here, I'm going to increase the force of gravity, and so then we end up getting to see, well, if we pull it faster, what happens to the acceleration that happens. First off, a little bit of theory. You're going to see this in your notes, not this week, but next week. There's an equation for force. Force equals mass times acceleration. And a nice easy one, it's only 3 letters. And might be a bit tricky to see there easily. Let's make it really big for you. Hopefully we can see that a little bit better. So F equals M times A. Now, the force in this case, the force is coming from our falling object. And we learnt last week a very important things about falling objects, about the rate that they accelerate at. Okay? And that acceleration is going to be equal to 9.8 meters per second squared. It falls at the same rate, it accelerates at the same rate, regardless of the mass. Okay? There is some effects of surface area, but we don't need to worry about it. A equals 9.8. That looks okay. Now, the mass we're going to change, but the mass off the end of that pulley we know. Okay, the mass hanging on the end, bring it up so we can have a look at it. This thing weighs 50 grams. So being as we know the mass of this, we could work out the force that it's pulling with. Okay? So let's talk about how we're going to run this experiment, because a lot of students make one big mistake when starting this experiment. My cart moving. My cart has a mass of 500 grams. I have my mass of my hanger that's pulling it down, and so if I had my 50 grams times 9.8 using Newton's law, I could work out the force that it's being pulled with, because all that force is coming up by the pulley, as we said, to the cart. So we could work out, well, if that's accelerating downwards at 9.8, then surely that's accelerating at 9.8. We won't know that though. We have to work that out. Because one thing all students have a problem with this at the start is it wasn't just the cart moving, was it? It was the cart and the mass. The whole system was moving, but only a small amount was getting pulled by gravity. Okay, so while the net force was indeed, we could figure it out using this, the mass of the hanger. I'm going to write this. My force, I'm going to go P, force P for pull force, equals the mass, I'll put a little H for the hanger, so the total hanging mass, times 9.8. We could do that. The acceleration for the whole system was not 9.8, and if we chuck that on, we should see that on SparkView. So right now this is measuring acceleration. We'll just let that stabilize a little bit. Good, and let it go. Now, let me just rescale this for us. Alright. Now this flat purple bit here at the top, okay, bit hard to see. You are going to get a copy of this Excel sheet, sorry, of this SparkView sheet, and I will rename all the runs so that you can follow along with it. However, it's only 1.5 meters per second. Why? Because it wasn't just the mass of the hanger, it was the mass of the entire system. Okay? And so while the force is being pulled, is the mass of the system times the acceleration of the system that will judge our force. So what we're going to do is we are going to gather some data about, well, how does the changing the mass being pulled, not the system mass, this, we're going to keep that constant. We're going to make sure that that doesn't change. So how can we change the hanger mass without adding more mass to the whole system? It's pretty easy. I'm going to take my little masses here. Again, each weigh 50 grams. So if that has 50 grams on there, and I add another 50 grams to it, then the mass hanger goes up to 100 grams. I'm just going to put these on top of my cart. Okay, so now I've added 1, 2, 3, 4, 5. 5 masses of 50 grams each to the cart. The cart already weighed 500 grams. And then I have another 50 grams hanging off the end. Another 50 grams hanging off the end of my rope here. Just go up a bit higher. Alright, so now run 2. Where's my stop? Let's just put my fingers here instead. Now, unfortunately, it's going to keep auto resizing for us. However, a bit hard to see. Here's 1, so we can see here that the acceleration, the rough acceleration there, was not equal to what it was before because I've added more masses to it. And if I turn the other one on, we can see that all the way there, it's way out of reach. Okay, so here's our second run. Okay, the one we're going to be working with our new system mass. And here we can see, well, now that's suddenly a lot higher. Okay, so what I'm going to do now is off screen, I'm going to work through all of them and I will label each of the runs. So the runs up here will say, okay, here's my my empty run, and then here's my run 2 will be called system mass 50 grams of pull, or 50 grams of pull. Then I'll do one for each of the masses as I move things over. And part of what you're going to have to do is you're going to need to work out, well, what is the acceleration roughly in that region. Now, the way we're going to do it, we need to use the statistic function. I taught you this last week. Remember, it's also on the written guide for how to find an average of a region. Okay, so if you're going through the video and you go, no, I didn't quite get that, go to the written guide. I wrote it so some of the teachers can follow it. You guys will be fine. I'll just grab this over. Let's move off to the side a bit. So, first things first, I need my highlighting tool. I'm going to highlight the green region. I'm going to highlight this top region here. And when you first highlight it, there's this little show hide statistics button that pops up above it. It looks like a sigma. We click on it, we got a great big menu, and I want the one that says mean, the average. Hit OK. And that tells me that during that region, there's a bit of variance. Okay, the track has little chips in it, things catch and run, so there's always some variance going on. We got an average acceleration there of 0.83. So that is how you're going to get your value for your acceleration. So at this point, I have an acceleration of the system that I just got from SparkView. I have a force pull from the system, a pulling force I can calculate using this formula, where the mass of the hanger right now is only the hanger, 50 grams, okay, times 9.8. Okay, so you are going to use that as part of your calculations this week and next. Thanks for listening, guys. Make sure you download the SparkView file. Have a great day.